Meet Marcus. He's building a wooden ramp for his school's science fair project, and his design requires a perfect right angle, or the whole thing tilts sideways. But he doesn't have a protractor. His teacher gives him a hint. Use the Pythagorean theorem to test it. Marcus stares at those 3 side lengths and wonders, how does a simple equation tell you if an angle is exactly 90 degrees? That's exactly what we're going to figure out today. Let's go. Before Marcus can test his triangle, let's make sure we know our tool. The Pythagorean theorem says, in any right triangle, if you square the 2 shorter sides, called the legs, and add them together, you get the square of the longest side, called the hypotenuse. That's a squared plus b squared equals c squared. Here's the key idea for today. This equation works if and only if the triangle is a right triangle. So we can flip it around and use it as a test. Here's the cool flip. We can use the Pythagorean theorem backwards. Instead of finding a missing side, we plug in all 3 sides and check if the equation balances. Step 1, identify the longest side. That's always your c, the hypotenuse. Step 2, call the other 2 sides a and b. Step 3, compute a squared plus b squared. Step 4, compute c squared. If both sides of the equation match, boom! Right triangle confirmed. If they don't match, it's not a right triangle. Simple, powerful, and no protractor needed. Marcus has a plan now. Let's lock in those 4 steps so we never forget them. First, look at all 3 sides and find the longest one. That's C. Second, label the other 2 sides A and B. It doesn't matter which is which. Third, square A and square B, then add those 2 results together. Fourth, square C, then compare. Are both sides equal? If yes, you've got a right triangle. If no, you don't. Let's put this to work with some real numbers, starting with the famous example Marcus's teacher mentioned. Let's start with the most famous right triangle in math, the 3, 4, 5 triangle. Marcus's ramp has sides of 3 feet, 4 feet, and 5 feet. Step 1, the longest side is 5, so C equals 5. Step 2, the legs are A equals 3 and B equals 4. Step 3, A squared plus B squared. That's 3 squared plus 4 squared, which is 9 plus 16, which equals 25. Step 4, C squared is 5 squared, which equals 25. Does 25 equal 25? Yes, so this is a right triangle. Marcus's ramp has a perfect right angle. Science fair, here he comes. Let's try a trickier one. A triangle has sides of 5, 12, and 13. Is it a right triangle? Step 1. The longest side is 13, so C equals 13. Step 2. A equals 5 and B equals 12. Step 3. A squared plus B squared is 5 squared plus 12 squared. That's 25 plus 144, which equals 169. Step 4. C squared is 13 squared, which is 169. Does 169 equal 169? Yes, this is another right triangle, a 5, 12, 13 Pythagorean triple. These special number sets always make perfect right triangles, and mathematicians love them. Here's a bonus insight that's really useful to know. When the equation doesn't balance, you can actually learn what kind of triangle it is. If a squared plus b squared is greater than c squared, all 3 angles are less than 90 degrees. It's an acute triangle. If a squared plus b squared is less than c squared, one angle is greater than 90 degrees. That's an obtuse triangle. Only when both sides are perfectly equal do you get a right triangle. 3 outcomes, 1 equation. The math is honestly amazing. Now let's catch a triangle that is not a right triangle. A triangle has sides 4, 6, and 8. Step 1. The longest side is 8, so C equals 8. Step 2. A equals 4 and B equals 6. Step 3. A squared plus B squared is 4 squared plus 6 squared. That's 16 plus 36, which equals 52. Step 4. C squared is 8 squared, which equals 64. Does 52 equal 64? Nope. 52 is less than 64, so this is not a right triangle. In fact, since a squared plus b squared is less than c squared, it's an obtuse triangle. Great catch! Let's try one more, and this one might surprise you. A triangle has sides of 8, 15, and 17. Looks random, right? Step 1. Longest side is 17, so C equals 17. Step 2. A equals 8 and B equals 15. Step 3. A squared plus B squared is 8 squared plus 15 squared. That's 64 plus 225, which equals 289. Step 4. C squared is 17 squared, which equals 289. Does 289 equal 289? Yes, it does. This is a right triangle, another Pythagorean triple. See, even big numbers can make a perfect right triangle. Marcus is totally impressed right now. One final example before we wrap up. A triangle has sides of 7, 10, and 12. Step 1. The longest side is 12, so C equals 12. Step 2. A equals 7 and B equals 10. Step 3. A squared plus B squared is 7 squared plus 10 squared. That's 49 plus 100, which equals 149. Step 4. C squared is 12 squared, which equals 144. Does 149 equal 144? No, 149 is greater than 144, so this is not a right triangle. And since A squared plus B squared is greater than C squared, it's actually an acute triangle. You're getting really good at this. Before you go ace that test, let's talk about the most common mistakes students make. Mistake number 1, using the wrong side as C. Always choose the longest side as your hypotenuse. No exceptions. Mistake number 2, squaring after adding instead of before. You must square each leg separately, then add. Don't add them first. That's a totally different number. Mistake number 3, sloppy arithmetic. 13 squared is 169, not 130. Little errors trip up a lot of students. Double check every multiplication. Get these right and you're unstoppable. Here's a secret cheat code that math champions memorize. Certain sets of whole numbers always form perfect right triangles. We call them Pythagorean triples. The big 3 to know: 3, 4, 5, 5, 12, 13, and 8, 15, 17. And here's the bonus. Any multiple of these triples also works. Double the 3, 4, 5, and you get 6, 8, 10, also a right triangle. Triple it, 9, 12, 15, still a right triangle. If you recognize a triple on a pest, you can skip all the calculation and just write right triangle. Talk about a superpower. Remember when Marcus was staring at his ramp with no idea how to check that right angle? Now he and you can test any triangle in 4 simple steps. Find the longest side and call it C. Square both legs and add them. Square C. Compare. Equal means right triangle. Not equal means not right triangle. From a confused builder to a geometry detective, that's the Pythagorean journey. You now carry one of the most useful tools in all of mathematics. Go practice a few on your own. And remember, every great mathematician started exactly where you are right now. You've got this.